speaker is Alexander Burstein, speaking on unjoint distribution of adjacencies, descents, and some Mahonian statistics.
Well, yes, before I start, I just wanted to say that being a student, former student of her quill, I guess it was almost predetermined that my first outside talk would be on Foata and Zeilberger's seminar then at Temple. And I actually, well, her told me that Doran is quite energetic and eurydic. But it turned out he was also very understanding. And when I asked him after the seminar if it was okay, and if he thinks that the audience may be minded that my talk went over time by 20 minutes. I think such was the combination of cluelessness and anxiety in my question. He said, no, I think they liked it. Anyway, well, so for a birthday present, I thought of something maybe small and handmade, and so there it is. I'm going to start with just the basic definition. So these are descents and inversions. Right? Descent bottom and descent top. It's greater and smaller element, and they give rise to two sequences of, to two families of statistics. Those that have the same distribution as descents, the Eulerian, and those that have the same distribution as inversions, called Mahonian. Well, some exceedance in the Eulerian statistics are strict exceedances or weak exceedances. Well, those have the same distribution up to a shift by one. And Mahonian statistics, for a while, there was just one. And then there was another one, was a little too difficult to describe, called Denier statistics. And then Foata and Zeilberger came up with yet another one called MAP. And then there was another one, MAD, and there was more of them. And it turned out that I guess one needed some kind of a system to describe maybe all of those that came up and maybe yet some more. So Babson and Steingrimson actually came up with a way to describe these, to come up with a lot of Mahonian statistics by writing them as a summary of pattern occurrence statistics. So what is a pattern? There's a definition, but it's easier to explain it by example. Right? So if you think of this pattern, so there's a point, there's an element, and somewhere to its right there's a descent across it. So this is like a 2, and somewhere to the right is a 3 followed by a 1. That makes a generalized pattern 2-3-1. So dash means they're not necessarily consecutive. No dash means they have to be consecutive. So in this way you can say that descents is just 2-1, right? They have to be consecutive and down. Inversions are 2-1, not necessarily consecutive. Major index is a little harder. Well, think about what you're counting for every descent. You're counting the position of descent top. So it's the descent top itself, and then everything before descent top. For MAP, you're summing descent bottoms, so you're counting the descent bottom itself, and then everything below the descent bottom, and then you're counting these right embracements, which is just the pattern 2-3-1. So think of a descent embracing the element to its left. Another statistics that they created we called stat, and then yet another that didn't give any name at all. So I thought I would match them in creativity. And then Euler-Mahonian bi-statistics or pairs of statistics are those that they have a certain generating function, but actually, we can say that they're the same distribution as the DAS match, the first statistic that would show to have this particular distribution. And one of the papers showed that DAS mat, one of the papers Foata and Zeilberger showed that DAS mat is Euler-Mahonian, and once these statistics came up, they proved that DAS stat and DAS blank are also Euler-Mahonian, and then several more. And the proof was, let me give you the outline of the proof. Here it is. So rather than reading through this, I'm just going to highlight the keywords here. Completely automatic and plug them in. Right? They're completely automatic. So there's the algorithm, and then you plug them in. So there's the proof. Right. Well, once Shalosh, Rota, and Percy have been there, there would be, and usually there would be nothing else left to do. But in this case, Nick Erickson of Göteborg University mentioned last year at the Permutation Patterns Conference this statistic called adjacency, which is a descent with descent difference 1. And it's kind of interesting because, well, if you think the adjacencies of phi, you have to sort of adjoin the 0 at the end so that, you know, there's the extra descent to 0. So if there's a 1 at the end, you know, just, yeah, they have an extra 1. So adjacency have the same distribution as the number of fixed points. And in fact, adjacencies descent plus 1 has the same distribution as fixed points and weak exceedances. And he used a bit of a complicated bijection to prove this, but I think it's pretty simple. And I'm going to sort of skip through this slide because, I mean, that's not the main thing I'm going to talk about. But it's just, you know, it's like an exercise for when you're going back home. And just think about it. It's like it should be straightforward, just to, you know, for when there's nothing to do. So once there's this statistic, and you can refine the adjacencies, you see, this edge this has the same distribution as fixed Wix, right? So once you adjoin match or map or stat or blank, the natural question is, do we get some triples that have the same distribution? And if we go back a little bit, you see that there's another keyword that I forgot to highlight. Is that the reason everything works fine, works nice here, is because they're nice Markovian permutation statistics. Well, once you, because the dashes are on the same side. Well, once you have the adjacencies, once you specify the size of the descent difference, I mean, there may be Markovian, and they're no longer nice. I mean, they're naughty Markovian statistics. So it turns out that these three, edge des and match, mat, and blank, they have distinct distributions. You can see them very early on. But edge des, adjacency descents in major index and adjacency descent in stat, so the heretofore pretty generic statistic they came up as part of a list of other statistics. This seems to have the same distribution as